Hello, this is Gregory Maxwell, and this lesson is about rectangular coordinates and triangles. This is a short lesson, less than half an hour, and it's an introduction to some basic concepts that will be needed for studying things like circles, for example. Today we're going to talk about briefly the Pythagorean theorem, the distance formula, midpoint formula, how to tell if points in a plane are either collinear or form a triangle, and also to identify from 3 points in a plane that form a triangle, what type of triangles those are, whether it's scalene, obtuse, scalene, isosceles, or equilateral, or right triangle, obtuse triangle, or acute triangle. Now let's start off quickly with a quick review of the Pythagorean theorem. The Pythagorean theorem deals with a right triangle. Pythagorean theorem deals with a right triangle. Um, the longest side across on the right angle is the hypotenuse, and the two shortest sides that form the right angle are called the legs. So if A is one leg and B is one leg and C is the hypotenuse, then the Pythagorean theorem says A squared plus B squared is equal to C squared in a right triangle. And likewise, I like to put it square of one leg plus the square of the other leg is equal to the square of the hypotenuse. Which means if we're trying to solve for the hypotenuse, we simply just do the square root of the sum of the squares of the legs. So C in this case would be square root of A squared plus B squared. Now, that comes up now with the distance formula. The distance formula is simply an application of the Pythagorean theorem to find the distance in the coordinate plane between 2 points. So let's say I have a coordinate plane here and I have 2 points, x1, y1 and x2, y2, and I have a line segment joining them. What is the length of that line segment? Well, first we realize that x1, y1 means the x-coordinate for this first point, x1, y1, is x units away from 0, x1 units away from 0, in this case to the left. It could be anywhere actually, but in my example it's to the left. And it's y1 units away from the origin, vertically downward. And for x2, y2, similarly, x2, the point is x2 units to the right and y2 units upward from the origin. Now, if I form a triangle with this, I just do a line segment that maps out the distance from x1 to x2 and from y1 to y2, and I find myself with a right triangle. And the length of one leg is x2 minus x1, which is second x value minus first x value, and the other leg is y2 minus y1, second y value minus first y value. And then the length of the line segment becomes the hypotenuse. And therefore, the hypotenuse, the distance from one end to the other, is simply the square root of the sums of the squares of the legs. One leg is x2 minus x1, so we square it and square the other leg, y2 minus y1, and we add those until the square root, and there we have our distance. And that is our distance formula. Now, let's talk a little bit about a quick couple of examples here, and then we will go on to some other applications. So let's take a quick look at this example here. We have two questions that we want to do here. One question says, find the x value such that these 2 points are 10 units apart, and find the y value so that these 2 points are 13 units apart. So let's see if we can do those. They're done similarly. So basically, I'll be doing the same question twice, just two different sets of variables. So based on the distance formula, we're saying that the distance is equal to the square root of the x2 minus x1 squared plus y2 minus y1 squared. Now, we know the distance is 10 units. And we also know we can call this guy x1, so we can call this x2, doesn't matter. So if I call this x1 and this y1, then this is x2 and this is y2. It doesn't matter which point I choose for x1 and y1 and x2 and y2, it will work out to be the same thing. So if you're more comfortable using the first point as x2, that's fine. So based on my notation here, I do -4 minus x squared plus 1 minus 7 squared. And now all I have to do is solve for x. This is a square root equation, so we square both sides. When I square both sides, I get 10 squared is equal to the square root of, well, I won't do that, that's understood. The square root will disappear. And all I would have now are my results. And 1 minus 7 is negative 6, so negative 6 squared. And since I only have one variable around, I just solve for the variable. So I have 100 is equal to negative 4 minus x squared plus 36. I subtract 36 from both sides. I get 64 is equal to negative 4 minus x squared. And then I take the square root of both sides. And when I take the square root of a number, I should get a positive and negative version. Square root of 64 is 8. So I have negative 4 minus x is equal to positive or negative 8. And then I just add 4 to both sides. So 4 plus or minus 8 is equal to negative x, which means that either negative x is equal to 4 plus 8 or negative x is equal to 4 minus 8. So negative x is equal to 12 or negative x is equal to negative 4, which means x is equal to negative 12 or x is equal to positive 4. And you can check, I'll leave you to check that. So the possible answers for x are negative 12 and 4. That means the x coordinate of this point could either be negative 12 or it could be 4. And that will make it 10 units away from this point that is indicated. Very simple. Next example. Same situation, so we're using the same approach. The distance between the 2 points is square root of x2 minus x1 squared plus y2 minus y1 squared. And this time I'm going to call this point x2, y2 and this one x1, y1. Same result, I'm just deciding to do it the other way around. The distance is 13, x2 is 3, and x1 is negative 9. We're squaring. And I just miswrote that there. That's x2 minus x1. And plus y2 is y, and y1 is 2. And then I proceed as always. I square the 13, that's 169. I square the right side, that causes me the square to disappear, the square root to disappear. And then that leaves me with 3 plus 9, which is 12. So we have 12 squared plus y minus 2 squared. 12 squared is 144. So 169 is equal to 144 plus y minus 2 squared. Subtract 144 from 169. And I believe that gives us 25. So we have 25 is equal to y minus 2 squared. And then we do the square root of both sides. Positive or negative 5 is equal to y minus 2, which means that y is equal to 2 plus or minus 5. That means y is either equal to 2 plus 5, which is 7, or y is equal to 2 minus 5, which is negative 3. So the possible answers then for my y coordinate are either negative 3 or positive 7. Either y here is going to be negative 3 or y is going to be a positive 7. Those are the possible values of y that would make this point 13 units away from this point. Okay, now let's move on to another application. Well, not quite an application here, another formula that we should know, the midpoint formula. The midpoint formula is basically the point, how do we find the coordinates of the point in the middle of a line segment, the midpoint. And the midpoint formula is derived from the process of starting at the first endpoint, in which case we're going to use the one on the left, and then adding half the distance from the first endpoint to the right endpoint, the left endpoint to the right endpoint. Now, you will do this for each coordinate. So let's see how we'll do this. So I have a line segment here. First endpoint is x1, y1. Right endpoint is x2, y2. And I want a midpoint. The midpoint is a point, say, right in the middle here, and I'll call that xm, ym. So I marked the x and y, corresponding x and y coordinates. And then what I'm going to do is I'm going to find the distance from here to here, and that's clearly x2 minus x1. And then I'm going to cut that in half, and that will land me right here. So half the distance from x1 to x2 is going to land me where xm is. And all I have to do is find out what that distance is and add it to the one on the left. So I start over with x1 and add half the distance between x1 and x2. I do x2 minus x1 because right minus left. Once I do that, I distribute the half, and then I combine like terms. x1 and negative half x1, those get put together. x1 minus half x1 is positive half x1. And then, of course, half x1 plus half x2 could be written as x1 plus x2 over 2. So that's how we get the x coordinate. And the y coordinate is achieved the very same way. We find half the distance from lower y value to upper y value, and then add that to the lower y value. And that gives us y1 plus y2 over 2. So the coordinates for the midpoints is x1 plus x2 over 2, comma, y1 plus y2 over 2. Those are two coordinates. Average of the x's, average of the y's. And there we have that. Now, let's do a quick example here with doing midpoints. So, two examples. Let's say we want to find the midpoint. We're given 3 points. One point is A, one point is B, and one point is M. A and B are the endpoints, and M is the midpoint. How do we find the missing point? So in this case, the midpoint M is xm, ym is the average of the x's, comma, the average of the y's. And so xm, ym is, in this case, we have A and B. So let's call A x1, y1, and B x2, y2. Again, it doesn't matter which one we choose, it will work out to be the same. So x1 is 2.8 plus negative 4.1. And we'll divide that by 2. And y1 is negative 3.5 and y2 is 7.6. So we add those and then divide by 2. And it is that simple. So let's add negative 2.8 plus negative 4.1, and that will give us negative 1.3, which we will then divide by 2. And negative 3.5 plus 7.6, that will give us positive 4.1, which we will also divide by 2. And then the midpoint then, which are the coordinates we're trying to find, would be negative 1.3 divided by 2, which is negative 0.65, and 4.1 divided by 2, which would be 2.05. And there we have it. We have the coordinates of M. In this question, we're given the coordinates of M. So we need to find the missing point, which is, in this case, A. If it was to find B, we'll basically be following a very similar approach. So what I'm going to do is write my coordinates, write my formula down. I strongly recommend that you write your formulas each time so that you get used to it and know how to plug it in. It's always good to show your steps. We'll write what we know. We know that xm is 2.5 and ym is 3.5. Now we know that x1, we don't know that. Let's call that the coordinates of A. Let's call those x1 and y1. So we don't know x1, but we do know x2. x2 is the x-coordinates of B, which is 12. And so that's the average of x1 and 12, and the average of y1 and y2, which is 10. And now all we're going to do now is do a little matchup. we know that the x coordinates match. So we know the x's will give you x, and the y's will give you y. So that's what we're going to do. So we're going to say x1 plus 12 over 2 is equal to 2.5. I multiply both sides by 2, and then I will subtract 12, and that will give me -7. And then for the y values, we know that y plus 10 divided by 2 gives us 3.5. And as before, same deal. Multiply both sides by 2, and then subtract 10 from both sides in this case, and we get y is equal to -3. So the coordinates of A then, the coordinates of A are -7 for the x coordinate and -3 for the y coordinate. And there we have it. Very simple if you know the concept and the process. I encourage you to practice numbers of these to get a good hang of them. Now, our next issue that we want to deal with is identify whether 3 points are collinear or whether they form a triangle. And if they form a triangle, what type of triangle do they form? So just remember, these are postulates and rules in mathematics. 3 points are always coplanar. They're always on the same plane. And the plane is basically a flat surface. Collinear points are points in the same plane that form a straight line, or they all lie on the same straight line. So if 3 points are not collinear in a plane, then they will form a triangle, and that triangle will be in only that one plane. The triangle inequality says that the sum of the lengths of two sides of a triangle is always greater than the third side. So if you have three lengths, say 3, 5, and 9, that would not be a triangle because 3 plus 5 is smaller than 9. And for a triangle, the sum of any two of those three numbers lengths must be greater than the third one. Greater, strictly greater, not greater than or equal to, just greater. Now, based on the triangle inequality, if 3 points are in the coordinate plane, then one of the two conditions is true. Remember, they either form a straight line or they form a triangle. If you find the lengths of the distances between all 3 points, between each pair of the 3 points, then if you add the two shorter distances and it gives you the longest distance, then those points have to be collinear. They form a straight line. Because otherwise they would form a triangle, and the other possibility is that the two shorter distances add up to be something greater than the longest distance. So we can tell if 3 points form a triangle or a straight line by just finding the distances and adding the two smaller ones. So basically, if we have 3 points and I find the distance from P1 to P2, the distance from P2 to P3, if I add P1, that distance P1, P2 plus P2, P3, and it gives me the same distance from P1 to P3, we're dealing with a straight line and the points are collinear. On the other hand, if I find P1 to P2, P2 to P3, and P1 to P3, all 3 pairs, and when I add the two shorter pairs or the two smaller numbers, I get something greater than the third. That will always happen. It's going to be equal to or greater. Then we have a triangle. And in fact, if you add any 2 pairs, you will always get something greater than the third pair. So when you have 3 points in the plane, those are the possibilities. Now, before we do some examples, just a quick reminder here. The Pythagorean theorem has a converse, which says if you have a triangle and you square all the side lengths and you add the two smallest squares and it gives you the longest one, you're dealing with a triangle. So if you have a triangle with side lengths A, B, and C, where A and B are the two shortest sides, if you add A squared plus B squared and you get C squared, you're dealing with a right triangle. Now, if in this case you can see it's an obtuse triangle, it's like I took this right triangle here and I extended the C, which means C squared is going to be bigger now than it was when it was a right triangle. So that would mean A squared plus B squared would be now less than C squared. And that will mean we have an obtuse triangle. So if the sum of the squares of the two shorter sides of the triangle gives you something that's less than the square of the longest side, you're dealing with an obtuse triangle, not a right triangle. And let me just make a quick correction here. We're dealing with an obtuse triangle. And now let's talk about the acute triangle, which you have seen, and you can easily guess that in an acute triangle, it's like we took the longer side and made it smaller. So that means a squared plus b squared is now going to be bigger than c squared. So if the sum of the squares of the two shortest sides is greater than the square of the longest side, then you're talking about an acute triangle. An acute triangle. Now, let's take a look at an example or a few examples here. In this example, the question is determine whether or not the points form a triangle. And if the points form a triangle, determine the type of triangle. And if not, find the equation of the line that on which the points lie. So either they form a straight line or they form a triangle. We want to tell what type of triangle, if it's a triangle, or what the equation of the line is. One way to find out is to find the slopes. Just find the slope from A to B, from A to C, and from B to C. And if those slopes are all the same, then you're talking about a straight line. But the way we're going to do this is to use the distance formula. So remember that the distance formula is square root of x2 minus x1 squared plus y2 minus y1 squared. That is the distance formula. So let's find the distance from A to B. The distance from A to B is a square root of, I'm going to use B as the second point, so I'm going to do 2 minus negative 3 squared plus 0 minus 5 squared. And we'll work that out. 2 minus negative 3 is 5, so we're talking about 5 squared plus negative 5 squared. And that gives us 25 plus 25, which is the square root of 50, which I can actually write that as 5 square root 2. Now let's take a look at B to C. So B to C now, and use C as a second point, so I'll do 6 minus 2 squared plus negative 1 minus 0 squared, and that will give me square root of 4 squared plus negative 1 squared. 4 squared is 16, and negative 1 squared is 1, so we're doing 16 plus 1, which is 17. And 17 cannot be broken down into something simpler. And then we talk about AC. Let's take a look at AC. AC will do C as a second point, so I'll do 6 minus negative 3 squared plus negative 1 minus 5 squared. And that will give us 9 squared plus the square of negative 6. 9 squared is 81, and 81 plus 36. 81 plus 36 is going to give us 117. Now, it turns out that 117 is divisible by 9. So that gives us 9 times 13 under the square root, which is 3 square root 13. Now, if you notice these, if you add AB, the two shortest sides would be square root 50 and square root 17. If we add those numbers, square root 50 plus square root 17, that works out to be approximately, and you can do this in a calculator, 11.1942. And I'll go to multiple decimal places here. But when you do the square root of 117, square root of 117 is 10.81. So this number is greater than the square root of 117. And that means what we're dealing with is a triangle. So we are dealing with triangle ABC. And now, since none of the sides are congruent, none of the sides are congruent, we're dealing with a scalene triangle because none of the sides are the same. Now, the deal is, we know it's not a straight line. The question, and we know it's a scalene because none of the sides are the same length. Question is it a right triangle or not? So what we need to do now is to square all the sides. So let's do AB squared is just the square of square root 50, which is 50. And BC squared is the square of square root 17, which is 17. And AC squared is the square of 117, which is 117. Oh, I need to go back and restate here. I made a misstep here. This is supposed to be the triangle inequality. Triangle inequality. So I misspoke and said it's an acute triangle. That's an incorrect statement on my part. What I should have said was, since the side lengths do not, the two shorter side lengths do not add up to be the same as the longest leg, then this is not a straight line, it's a triangle. And that's a triangle inequality. What we're testing over here now is if we have an acute, obtuse, or right triangle. Now the two shortest squares, a squared plus b squared, ab squared plus bc squared. That gives us 50 plus 17, and that is equal to 67. That's definitely less than 117. So AB squared plus BC squared is less than AC squared. And when that happens, we're dealing with an obtuse triangle. So we say, therefore, triangle ABC is an obtuse triangle. So one more time. This over here tells us whether we have a triangle or not. And this over here tells us what type of triangle, if it's obtuse, acute, or right triangle. That if the two shorter lengths are equal to the longest length, we have a straight line. But if the two shorter lengths are not equal to the longest length, they'll be greater, and then you have a triangle. If you square all the lengths and you add the two smaller squares, if you get something that's equal to the longest square, that's a right triangle. However, in this case, the sum of the two shortest squares is smaller than the longest square. So we're dealing with an obtuse triangle. Our next example, same instructions. This time, however, we're dealing with 3 different points. And let's see what happens here. As before, we will write our distance formula. D is equal to square root of x2 minus x1 squared plus y2 minus y1 squared. And we'll find our side lengths. LM is equal to the square root of, I'm going to choose M as the second point, -3 minus 0 squared plus 5 minus -7 squared. And -3 minus 0 is -3, so that's 9 when we square it. And 5 minus -7 is 12. So we're dealing with 9 plus 144. 9 plus 144 is 153, which is, if you think about it, is 3 square root 17. Then let's do M to N now. Mn is a square root of 2 minus -3 squared plus -15 minus 5 squared. And then we'll work that out. 2 minus -3 is just 5, and -5 minus 15 is just -20. So we're squaring -5, that gives us 25, and the square of 20 is -20 is 400. So we're talking about 425. And we can divide that by 25. So you will simplify that radical to be 5 square root 17 because 25 times 17 is 425. And let's talk about ln. ln, we will now do, we have 2 minus 0 squared plus negative 15 minus negative 7 squared. And let's see what that gives us. That's 2 squared plus negative 8 squared. And negative 8 squared is 64, and 2 squared is 4, so let's get square root of 68, which is divisible by 4. That gives you 2 square root 17. And so now we know that in this case, Lm and Ln are the two smaller sides. When we add those up, Lm plus Ln, that gives us 3 square root 17 plus 2 square root 17. That gives us 5 square root 17, which is the length of Mn. So what we're dealing with here is a straight line. So L, M, and N, L, M, and N are collinear. They form a straight line. And since we have a straight line, we're not talking about triangles anymore. We're talking about a linear equation. So let's talk about part B here, equation of the line. To find the equation of a line, we need the slope. The slope of a line, as you recall from earlier math, is change in y, y2 minus y1, over change in x, x2 minus x1. And let's say we choose 2 points here. Let's choose L and M. So let me make a little space here. And using points L and M, we have L is 0, negative 7, and M is negative 3, 5. So we do 5 minus 7, y2 minus y1 over negative 3 minus 0. That gives me negative 2 over negative 3, which is 2/3. Oh, I think I miswrote this. That's 5 minus negative 7. That's important. It's an error that I should not have made. So 5 minus negative 7 now is now positive 12 over negative 3. So the slope is no longer 2/3. It's actually negative 4. And so since L is 0, negative 7 is on the point, is a point, then the y-intercept is negative 7 because the x-coordinate is 0. So the equation then in slope-intercept form, the equation is y equal to m negative 4x plus b. Just put it here, y equal to mx plus b. And that is our answer, y equal to negative 4x minus 7. That's the point that has all three, the line that has all 3 points. If you plug in 0 for the x-coordinate, you will get negative 7 for the y. If you plug in negative 3 for the x-coordinate, you will get 5 for the y. So let's take a look at that. Negative 3 times negative 4 is 12. 12 minus 7 is 5. If you plug in 2 for x, you should get negative 15. Negative 4 times 2 is negative 8. Minus 7 is negative 15. So all 3 points are on that line. Last example. In this case, we want to find the same information, same stuff. We're going to use the same approach. The distance here is equal to square root, and this formula you need to know, as well as the midpoint formula, x2 minus x1 squared plus y2 minus y1 squared. So let's find the distance from P to Q. PQ, the distance is square root of 0 minus negative 6 squared plus negative 2 minus negative 4 squared. And of course, this is going to be 6 squared plus another 2 squared. 6 squared is 36. 2 squared is 4, so it's square root 40, which is 2 square root 10. Now let's do QR. QR, we have negative we have negative 10 minus 0 squared plus 8 minus negative 2 squared. And that gives us negative 10 squared plus 10 squared. And that's what will give you square root of 200. And the square root of 200 is 10 square root 2. And then for PR, same approach. We'll do negative 10 minus negative 6 squared plus 8 minus negative 4 squared. And negative 10 minus negative 6 is negative 4. So we have the square of negative 4, which is 16, plus the square of 12, which is 144. And 16 plus 144 is 160, which works out to be 4 square root 10. Now, the two shortest sides are square root 40 and square root 160. So we're going to add those two shortest sides and see if we get the longest side. Square root 40 plus square root 160 works out to be approximately, well, that works out to be 2 square root 10 plus 4 square root 10, which is 6 square root 10, which is approximately 18.9736. The thing is, though, when we do the square root of 200, that gives us 14.14. So that is bigger than the square root of 200. And therefore, by the triangle inequality, so then we have PQR. So triangle PQR. We have a triangle PQR. They are not collinear. And since none of the sides are congruent, there's also scalene. If two of the sides were congruent, that would be isosceles. But this is scalene. Now we need to know if it's a right triangle or not. So we're going to do the squares. PQ squared is the square root of 40 squared. And that's just 40. And QR squared is the square root of 200 squared. And that's just 200. And PR squared is the square root of 160 squared. And that's just 160. And let's add the two smaller pieces, which are going to be PQ squared plus PR squared. And that would be 40 plus 160. That equals 200, which happens to be the square of QR. So PQ squared plus PR squared is equal to QR squared. So we're talking about an scalene right triangle. So triangle PQR is a scalene right triangle. And the hypotenuse is going to be the longest side, which in this case is QR. That's it. That is the process. That's all for this. I will encourage you to check out some additional videos on Khan Academy with similar approaches and also practice. That's all for now. And please make sure that you are following up with practice. It's not enough to just review mathematics or watch someone else do the work. You need to practice as well. All the best. Till next video.